Good morning. Today we'll be looking at exceptions to Mendel. All right, so if you remember, Mendel always had a dominant and recessive. Today we're going to look at what happens when you have two dominants, really, that get together. Okay? All right, so Mendel's preference principles are not laws. They're just Mendel's principles because some alleles are not dominant or recessive, and many traits are going to be controlled by multiple alleles, not just a big A and a little a or just two choices. It's going to be like blood type, skin tone, that type of stuff. Okay? So they're called principles, not laws, because some alleles are not dominant or recessive, and he thought they all were either dominant or recessive. But Mendel had good ideas. Okay? So the first thing we're looking at is incomplete dominance. All right? This is when one allele is not dominant over the other, so it's incomplete. So this would be when you have a red flower crossed with a white flower, and it makes a pink flower. All right? So in the past, we were looking at maybe red being dominant, and if you had the capital letter and it was always red. In this case, you have a red flower, which is dominant, and a white flower that's dominant, but neither one is showing dominance over the other. So they make a pink flower. So if you notice the Punnett square here, we don't use the same letters. We use, for the red, we use two capital R's because it's dominant. And for the white, we use two capital W's because it's dominant. But in the middle, everything is RW. So in the middle, everything being RW is going to make all pink flowers. If you start crossing RWs with RWs, then you're going to end up with some pink flowers, some white flowers, and some red flowers. All right. We also have codominance. This is when both alleles of the gene contribute to the physical characteristic of the organism. So think about coworkers. We both do the same thing. We're both doing it. All right. So this would be if you have a chicken with black feathers and a chicken with white feathers, you cross them, you're going to have a chicken that has black and white feathers. Okay. So it's a little bit different, not making it gray, but making a chicken with black and white. So both of these are showing. So incomplete dominance, they blend because neither one's a leader. Neither one is completely dominant. In codominance, they're both dominant. So they're both showing, okay? So example would be red cows crossed with white cows generate something called roan cows, and this is roan right here. And roan refers to, you have coats that are red and white with blotches everywhere on there, okay? All right, so that's how you do those two. Then you also have things that have multiple alleles, not just A or B or capital A, little a. Blood form, a blood type, is the most common you'll see on test. And we have three different types of alleles. There's A, B, and O, okay? But there's also blood types, can be A, B, AB, or O, all right? It's a little bit different. All right, so you can sort of see the phenotype, which is the physical characteristics. So you're either type O, type A, type B, or type AB. The genotypes that can give you these is O. So OO, like O's recessive, really, okay? All the other A and B are both dominant, okay? So to be A, you can be AA or AO. But again, to be O, you have to be OO. To be B, you can be BB or BO. If you have A and B come together, it's A and B type. It's type AB blood, okay? So O's are recessive, A's and B's are dominant. So if you're crossing these things, so if you have like an AB crossing with an AO, it's going just like this. But you look at the types on here. So a quarter of them are going to be AB. A quarter of them are going to be type B, right? And then a half of them is going to be type A because AO, remember, O is recessive. So this is type A blood. Again, this is type B blood. If you cross over an AO with a BO, all right, so they're both type A and B, but they have that O allele in there. So AO, BO, you have a quarter AB, a quarter B, a quarter A, and also a quarter type O negative. All right. So just remember, A and B are dominant, O is recessive. All right, then you also have polygenetic traits, and these are ones that have more, like they need more than one gene to contribute to the phenotype. So the skin color is a great idea. The current model of skin color is 3 genes that combine to contribute to skin color. So that's a total of 6 alleles. 3 from the mother, 3 from the father. That's how you get your skin tone. That's why all races have different skin tones. You're getting 6 different alleles coming together to form